Hello, friends. Welcome to this special episode where we depart from our usual cadence of solving competitive programming problems on HackerRank and get to do some fun stuff on our own. Well, in the last episode, we used the sort function provided in the data.list module in our solution. If you haven't watched that episode yet, please check it out from the link you see at the top right here. Anyway, I had mentioned that using the library sort function is the easiest choice that you can make, but you can also implement your own sort function. Well, some of the subscribers reached out to me to ask how we can do just that. So that's what we're going to look at in today's episode. Let's implement our own merge sort. Before we jump in, I want to quickly run through some Haskell specific syntax so that our explanation will make more sense to you. So where is a keyword in Haskell and you use it to define the sub-expressions that you use to define the function as a particular expression. So for example, here you have a simple f of x function, which is basically a constant. It always outputs 5. But you can define this f of x as g plus h, and these are the sub-expression. And then you can define the sub-expression on the next line using where keyword. Now here we can say g is equal to 2 and h equal to 3, and then this code will compile. And the good thing is that you don't need to have these as constant expression. You can say f of x is g of x plus h of x, and then here you can define those function definitions as g of y, well, let's say 2 into y, and then h of y is equal to 3 into y. So here basically we are saying that f of any function is basically 5 times that number. Now the next thing is pattern matching. So what pattern matching does is it lets you define the function expression where you can pattern match the arguments that are provided and then define the function expression that way. So here isEmpty will receive a list of something, and then it's going to tell you whether it's empty or not. And then I can do the pattern matching here, saying that if the argument provided is an empty list, then it's true. If it is anything other than that, then it is false. And that is basically the pattern matching on the given argument. You can do this on any number of arguments that the function has. And the last syntax we're going to looking at will be the guards expressions. So it's basically same as pattern matching, but here you provide a guard on the variable that you want to switch on. It's basically what you see in Java programming language as the switch statement, where you just have a bunch of conditions and there is an otherwise condition which is kind of a catch-all. If none of the other conditions match, then you basically go to otherwise clause. And it's the same implementation of the isEmpty function that we saw earlier. So armed with all the knowledge about the syntax we have seen so far, let's implement our merge sort. So for the merge sort, we'll define two functions basically. One is merge sort itself, which takes a list of some type and then returns the sorted list. Now, in order to this list to be sortable, we basically need the elements inside that list to be orderable themselves. So we'll add that ORD constraint so that the elements themselves are orderable. And the implementation of merge sort right now doesn't matter. Okay, so we'll just keep it undefined, and let's see if it compiles. Okay, it does. And then the second thing we want is we want the merge function, which given or a constraint and given the list of basically two sorted list of left and right that we have already sorted during the merge sort step, we need to merge them into a single sorted list. So merge, let's say left, right equal to undefined. Okay, good. So let's start implementing. So we'll use the pattern matching that we have seen. So basically we say merge sort on any empty list is just an empty list. Merge sort on any list containing just one element is the same list again. And then on the all other cases, we do merge sort excess is equal to, we basically assume that we are going to merge sort left and merge sort right. correct? And then we are going to say just merge them. Now what exactly are left and right here? So that's where we are going to define with the where expression. So first we need to define like the breaking point in which we will use basically to split the list into left and right. So let's call it pivot. Okay, and then we can say that pivot is just the midway point. So length of the list, and then use the division operator for integers, and then divide by 2. And in order to take the left part, we can say that we just take pivot number of elements from the list, right? And that will be on left. And then for right part, we basically just remove whatever we have taken in the left part. So we do that by saying drop pivot list. So there, merge sort implementation itself is done. I made a typo. Let's LENGTH, right? List itself. Oh, we are calling it XS. Let's call it a list. And there you go. The merge sort is done. Now we need to implement the merge function. Okay. We are again going to use some pattern matching here. So we can say that if it's an empty list, the left one is empty, and then whatever we have on the right part, we just return the right part. Same goes for the left part. So if right is empty, we just return the left. And then if both of them are non-empty, then we basically choose some element from either the left one or the right one. Is going to be the smaller of the two. And then we merge the left prime and right prime. So that's a recursive call. Now what are these left prime and right prime and L? Okay, let's define that with where expression. So L is basically minimum of either the first element of left or the first element of right, correct? And your left prime will basically be determined by whether you chose the element from the left list or the right list. If you chose the element from the left list, then left prime would be the tail of the left list now, because you have already chosen the first element, and same goes for right. Right? If you had chosen the right element, then your left prime would be just the left. So how do we do that? So let's say we define something based on whatever the element we chose, right? And again, choose is a function we haven't yet defined. We are still in the where clause, so we're going to define that once we do define the right prime expression. So it's going to be choose, and then let's flip the arguments here, right, left. Okay, and then what choose is going to do is it's going to get list 1 and list 2, and then we're going to pattern match on that. So we're going to say let's compare the head of L1 and head of L2, right? Which one is the smaller one? Okay, and if it is equal to GT, basically what compare does is it says compare 1 with 2, it says less than. If we do 2, then it's going to say EQ, and then compare 3, 2 is going to say GT. So basically, if your head of the list that you're going to choose is greater than the head of the list 2, then but you're just going to say take the list 1 because you chose the smaller element there, right? So you're going to say I chose the element from the L2 list, so my L1 prime is going to be just the L1 list, okay? And we're going to do the catch-all clause here, which is otherwise, which is going to take care of EQ and LT cases, and that's going to be tail L1. And that is our merge sort, ladies and gentlemen. So there you go. You have now implemented your own merge sort in Haskell.